So after we find out the shear moment function from the previous step, then the next thing is try to draw the shear moment diagram. So we know, so what you are going to do, when you cut at A, which means your x equals to 0, so you put 0 in, you find out, okay, we are going to have 30 as our start point. And then nextly, you can try to plug in x equals to 18, which is the B point here. What is the shear value here? So after you do the calculation, you find out it's negative 42, which matches with our shear, the total resultant force from our first step. So now how we are going to connect these two dots together is following the function. You can see this is square, so which means we are going to use a parabola, try to connect these dots together. So it will be a parabola like this. However, take a look at here. What we are going to have is we had a point that shear force equals to 0. What does this mean? It means that on the moment diagram, dm over dx here is going to have a slope equals to 0, which is the highest point. So which means we are going to have the maximum value on the moment diagram. So whenever you had shear force equals to 0, add another vertical line, because at this line we are going to have the maximum bending moment. So now let's take a look. Do you know what is the distance from here to the 0 location? No, we don't. So how we are going to figure out exactly this distance so that we can plug into the moment function to find out exactly what is the maximum value we are going to have on the moment diagram. So we have to find it first, and this is how. So remember, we had shear function equals to 0. So now let's take a look at this equation. Can we solve the x from this quadratic equation? Yes, we can. So we had x1, x2, so which one will be our reasonable answer? Can we choose negative 27? No, that's not reasonable. So which means we are going to pick the answer 9.735 feet. We know exactly where we had shear equals to 0. So what we do is try to find out what is the maximum bending moment at this location. So which means we are going to plug into the distance we just found into the moment function. Finally, we find the maximum bending moment. It's 163 caps feet. So which means we had 163 as our maximum bending moment. And then you can plug x equals to 0 into this equation. You find out at the beginning will be 0, and when we plug into 18 we had another 0. So what we can do is we are going to see here is x cubed, which means we are going to have a cubic curve to connect these dots together, and that's going to be your moment diagram.